right? When we do domains, we talk about if I would go from left to right, what x values am I hitting? What I want to practice now is finding the domains when we are looking at equations without actually drawing a graph. Can I just look at a problem and tell the domain? For you, there are two main rules you need to remember. In a fraction, the denominator cannot equal 0. So if I'm asking you to find the domain, first thing you're going to say, okay, is it a fraction? If it is, I know the bottom can't be 0. The second rule has to do with radicals. And an even radical. So that means if I have a square root, a fourth root, a sixth root, those types of things. The radicand, the thing under the radical, has to be greater than or equal to 0. So you're going to say, okay, does it have a fraction? Does it have an even radical? If it doesn't have either of those two things, your domain is automatically negative infinity, positive infinity. If it does have those, then we have to take a little bit of time and work out what our actual domain is. Okay? We're just going to go through problems and practice. So here is our first one. F of x equals 3x squared plus 2x minus 1. All right, does it have a fraction? Does it have an even radical? So what is my domain?
Negative infinity, positive.
All we are doing on every one of these problems is finding the domain. So this is just negative infinity, positive infinity. Okay. Number 2. F of x equals x over 2 plus 1. Has a fraction. If it's a fraction, I know the denominator can't be 0. My denominator is 2. So 2 can't equal 0. Does 2 ever equal 0? No. So what's my domain?
2.
It can be anything. So if I look, my denominator is 2. But since that doesn't equal 0, it means no matter what, I can plug in a number, divide it by 2, and add 1, and get an actual answer. My calculator is not going to tell me error if I plug anything in. So I can plug in any number in the world there. Okay, questions so far? Keep trying. 2x over x minus 3. So it has a fraction, which automatically tells me what? The denominator can't equal 0. So x minus 3 cannot equal 0. So if I solve that, add my 3 over, x cannot equal 3. Okay, if I want interval notation, this is saying x can be anything except 3. So we would write negative infinity to 3 with the parenthesis, union 3, comma, infinity. Is that one right? All right. Number 4. Does this one have a fraction? No, but I have a square root. So if it's even roots, the thing underneath, so my x minus 1, has to be greater than or equal to 0. So if I solve for x, that means x is greater than or equal to 1. How do we write that in an interval? Half of that. It's only the things bigger than 1, so it's just the bracket 1 to infinity, not the things less than. Okay, we'll do a couple more together and then I'll have you guys try some. Okay, so I have a radical. What am I going to write? Okay. So we add our 3. Divide by 2. So x is greater than or equal to 3 over 2. So I would write, good.
Will there always be an infinity somewhere?
Yes. On all of these there should be. Number 6. This one's a fraction. So we know if it's a fraction, the bottom can't be 0. So x minus 2 times x plus 1 can't be 0. If you have things multiply, what we really need to do is figure out what makes each one of those 0. What would make x minus 2 0? Okay, what makes x plus 1 0? So what we get is x can't be a positive 2 or a negative 1. On these problems, if you wanted to write the interval notation, it becomes a little bit longer. If you think about this, it's saying you can't be negative 1, so you could be anything smaller. You can't be positive 2. So the interval notation here is actually negative infinity to negative 1. Union, negative 1 to 2, union, 2 to infinity. So it becomes a little lengthy. What I have told you in the past is that if there is more than one value x cannot equal, I will allow you to just list them. So on this one, I would accept, the interval notation is great, but if you left it as x cannot be negative 1 or 2, I will accept that. Now on the problem a little bit ago when we had x cannot equal 3, I do want the interval. So if it's just one value x can't equal, go ahead and give me the interval. If it's more than one, you can just list it and say x can't be those things.
Will there be a lot like that?
There could be. Alright. You guys ready for a couple? It has a fraction. In a fraction, you know the denominator can't be 0. Can 2 equal 0? No. So we've already had one similar to this. So you have the fraction, but it doesn't equal 0. So what does that mean our domain is? Okay. Number 8, I have a square root. If I look, the thing under the square root is just x. So what this means is x has to be greater than or equal to 0. So nothing really to solve there. That's just bracket 0, comma, infinity. If you are struggling with how to write the interval, you could always draw yourself a graph. Greater than or equal to 0 would be starting at 0, going to the right, so then you can see it is 0 to infinity. So if you're not sure about the interval, draw a picture to help. All right. How'd you do on those? Okay, so we need to keep practicing. Just keep doing them then. This one, number 9. We have a radical. So what do we know? So x squared plus 2 is greater than or equal to 0. Okay. We can figure this out a couple different ways. You guys all have graphing calculators in front of you. Graph x squared plus 2 for me real quick. You get something like this, right? You're welcome. Okay, so does this graph ever equal 0? No. Is it ever less than 0? No. If you had tried solving this and setting when it was equal to 0, you would have subtracted your 2 over, and then if you had done the square root, you would have had an imaginary number, wouldn't you? So we could figure this out from the graph, like when we did those quadratic inequalities earlier on. We could think about solving this. If you square a number and add to it, it's positive no matter what. So this is never less than 0 as it is. So what's my domain? We know that the thing underneath the radical can't be negative, right? But we just found out it's never negative. So no matter what I put in, it's still a positive number. So you can put in anything. Okay, if it had just been like an x plus 2, and you'd solve that, and then you would have had x plus 2 is greater than or equal to 0. X would have had to have been greater than -2. Come in. If you put in something smaller than -2, like a -5, you would have gotten the square root of a negative number, which doesn't exist. That's what we're trying to avoid. We want real answers. But here we found this thing's never negative, so no matter what x value I plug in, it'll be a positive under this radical, so we can get an answer.
Okay. So the negative infinity you want to cover that.
Right. Mackenzie, did you have a question?
I was going to
If it was x squared minus something, no. But because it was x squared plus, it worked out that way.
So why wouldn't it be 0? Because I thought that, because it's never negative, it doesn't make sense to me.
Okay, when I say never negative, I mean the y's are never negative. So even if you plug in a negative x, you're still getting out a positive y, so it's okay. Other questions? Let's look at number 10. So we have a fraction. What do we know? Okay. Could we factor this? X squared minus 4x, what would we do? So So what can x not equal?
negative 4.
What makes x minus 4 0?
Oh, 4.
Positive 4, and this out here we would just need 0. Just like when you solve the quadratic, we would factor them and we set each piece equal to 0. So basically this means x cannot be 0. X minus 4 cannot be 0. So we get x can't be a 0 or a 4 on this problem. Since it's more than one value that x can't equal, you can just list them. Questions there? Do you have a question? Just stretching? Yeah. Let's do some more. Hold on. I'm going to change this real quick. I want to do this 4x minus 9. Sorry about that. Okay. So it's a radical. So what do we know? So add your 9. Divide by 4. So x is greater than or equal to 9 over 4. How do we write that? Bracket 9/4, comma, infinity. Alright, number 12. This has both. Has a fraction and a square root.
So it can't equal 0.
Yeah.
So it'll just be an open.
Yes, very good. It's a radical, so the thing under the radical, we normally just say greater than or equal to 0, but since it's also on the bottom of a fraction, you can't have that equal. Why is my eraser not working? So that x just has to be greater than 0. So it'll be like an open circle, parentheses 0, comma, infinity. That's our domain. We're going to do about 4 more, and then I'll be done. So there's 2 things we're looking for on every problem. So we're doing the same things over and over again. I want to change this problem too, I think, actually. I'm going to make this the square root of 1 minus x over x plus 2. Okay. So on this one, we have again both. But this time it's not the radical on the bottom, so we need to treat both parts separately. So this, we know the thing under the radical is greater than or equal to 0. This, we know that if you have a fraction, the bottom can't be 0. So we're going to have to solve both of those. So the first one, if I subtract my 1, if you divide by a negative in an inequality, what do you have to do? So x is less than or equal to 1. X can't be negative 2. I'm going to draw a picture to help us graph or write the solution for this. less than or equal to 1 would look like that. Cannot equal 2 or negative 2 is everything except the negative 2. So it would look like that, correct? We want the overlap. We want the numbers that worked for both of them. So both of them have everything smaller than 1 with the exception of negative 2. Negative 2, and we have to stop at 1.
Why couldn't we just go from the 1 and down? Because we have to show that the 2 is open and the...
Yeah, so it's basically everything smaller than 1 with the exception of negative 2. So that's why I had to separate it at negative 2 to say that that one number did not work. Other questions? I don't have a fraction. I do have a radical, but what's underneath it? A 2. Do we have to worry about that? There's no variable? No. If you were trying to work it out, it's just the thing under the radical is greater than or equal to 0. There's nothing to solve there. 2 is greater than 0. Since my variable isn't under the radical, my domain is just negative infinity to positive infinity. I can plug in any x I want there. Couple more. Alright, this one has both again. So the radical portion, we know the thing under the radical, greater than or equal to 0. This one we know it's a fraction, so the bottom cannot be 0. So if I add my 1 over, x is greater than or equal to 1. This one, x can't be negative 3. If I were to graph this, greater than or equal to 1 would be like a 1 going this way. Not equal to negative 3 is everything except negative 3. What's the overlap? What got shaded by both of them?
The 1 to the negative.
Just the 1 on, isn't it?
Yeah.
So my final answer would be bracket.
1, 0,
Yeah. Last one, I'm going to change my example again here. Some of my examples were a little bit uglier than the problems we've solved so far, so we'll save some of the uglier ones for later on in the semester when we do a little more with those. Yeah, sometimes I'm nice. It's rare.
So this one it has to be greater than 0, right?
Greater than or equal to.
Yeah.
Uh-huh. So then what do you want to do?
Subtracting 1.
And then,
Divide by 2, negative
which flips our inequality. So less than or equal to 5/2. If you need to, draw yourself a picture. You have 5/2, you are at everything smaller than that. So what would my interval notation be?
5, bracket, 5 halves, and negative.
And I'm just going to flip that and write the smaller one first. So negative infinity, comma, 5/2 with a bracket. Okay.
So you always want a negative infinity on the left side.
Yes, you always go small to large. Questions? So we just walked through 16 practice problems here. Basically, what I want you to realize is there's only two things to worry about: the fraction and the radical. If you don't have those, your domain is automatically negative infinity, positive infinity. For homework, I posted on Classroom a handout. There are 12 questions on it. You've got some time right now to work on them. So just 12 questions. All you're doing is finding domains.